This section describes the 5G paging procedure which is applicable to base station architectures which allow the UE to camp on the 5G system in RRC idle. For example, this section is applicable to the standalone base station architecture option 2 which is based upon a 5G base station connected to the 5G core network. The 5G paging procedure is not applicable to non-standalone base station architecture option 3 which is based upon a 4G anchor base station providing control plane connectivity to the 4G core network. In that case, the UE camps on the 4G system in RRC idle mode and the 4G paging procedure is applicable. The 4G and 5G paging procedure is very similar, but there are some important differences. For example, the 5G paging procedure does not allow a UE to be addressed using its TMSI. UE listen for paging messages while in RRC idle and RRC inactive. Paging messages allows the network to initiate mobile terminated connections. The core network is responsible for RRC idle paging procedures, whereas the serving base station is responsible for RRC inactive paging procedures. The additional category for paging is applicable to UE in RRC connected, RRC idle, and RRC inactive. This additional category is applicable when there is a requirement to notify UE of a change to the system information or an incoming ETWS or CMAS message. In these cases, the paging procedure does not use NGAP nor RRC paging messages. Instead, the paging procedure uses only the payload of the PDCCH downlink control information DCI format 1_0 can include a short message when the CRC bits are scrambled using the I-RNTI. This short message can be used to indicate that system information has been updated and needs to be reacquired, or there is an incoming ETWS or CMAS message. For a UE in RRC idle, the AMF maintains a record of the UE location in terms of its register tracking areas. The UE triggers a NAS registration procedure with cause value mobility registration updating if it moves outside the register tracking areas. The UE does not update the network while moving within the register tracking areas. In general, this means that paging messages must be broadcast by all base stations belonging to the register tracking areas. This tends to generate a relatively high paging load, especially for large tracking areas which capture a large number of UE. Specific core network implementations may make certain assumptions regarding the UE location. For example, if a UE releases its connection from a specific base station and then a paging procedure is triggered 30 seconds later, there is a high probability that the UE has remained within the coverage of the same base station. In this case, the AMF may end the paging message to only that single base station rather than all base stations within the registered tracking areas. If the paging attempt is unsuccessful, then the AMF can resend the paging message using the full set of base stations. This type of solution reduces paging loads at the cost of increased delay for UE which have moved to different base station. Figure on the screen shows an AMF completing the paging procedure for a UE in RRC idle. The UE uses discontinuation reception DRX to delay for UE which have moved to a different base station, help converse UE battery life, while in RRC idle, that is, the UE receiver enters a sleep mode between periodic paging occasions. At each paging occasion, the UE scans for a PDCCH transmission which has its CRC scrambled by the P-RNTI. All UE share a common P-RNTI value of FFE. Downlink control information DCI format 1_0 is always used when allocating PDSCH resources for a paging message. The UE determines its paging occasions using a combination of information broadcast in SIB1 and its allocated 5G STMSI. The AMF is responsible for providing UE reachability services for other network functions. For example, an SMS function SMSF may have received an SMS addressed to a UE which is registered with the AMF. In that case, the SMSF requests the AMF to initiate the paging procedure before forwarding the message for delivery. Alternatively, a user plane function UPF may have received downlink data which is addressed to a UE currently in RRC idle. In that case, the UPF notifies the SMF that downlink data has arrived and the SMF requests the AMF to initiate the paging procedure. The UPF can subsequently forward the downlink data to the base station once the UE has entered RRC connected and the base station has set up a GTPU tunnel with the UPF. The AMF starts the T3513 timer when sending the N-gap paging message to a base station. This timer serves as a supervision timer for the paging procedure. The AMF assumes that the paging procedure has failed if T3513 expires before receiving a response from the UE. This may trigger the AMF to initiate a retransmission for the paging message. Here is paging. The N-gap paging message is represented in table on the screen. Only the UE paging identifier and TAI list for paging fields are mandatory, so the remaining fields may be excluded from the message. The base station uses the UE paging identity to address the UE within the RRC paging message. This identity corresponds to a 5G STMSI, which is concatenation of the AMF set identity, that is 10 bits, the AMF pointer 6 bits, and the 5G TMSI 32 bits. The 10 least significant bits LSB of the 5G TMSI are used to determine the paging frames and the paging occasions for the UE. The AMF is responsible for ensuring that the population of UE are allocated 5G TMSI values which evenly distribute the UE across the set of paging frames and paging occasions. The 5G STMSI is used instead of the IMSI when addressing the UE because it is temporary identity. The use of a temporary identity helps to improve security by avoiding exposure of the permanent UE identity. In contrast, the S1AP paging message used by 4G allows the UE to be addressed by either its IMSI or STMSI. The paging DRX field can be included to ensure that the base station determines the correct DRX pattern being used by the UE. The base station broadcasts the default DRX cycle duration within SIB1. The base station also provides this default DRX cycle duration to the AMF during the NG interface setup procedure. The AMF may negotiate a UE-specific DRX cycle during the NAS registration procedure. This negotiation is transparent to the base station, so the base station may not know the DRX cycle being used by the UE. The AMF can also use the core network assistance information parameter structure to provide the base station with information regarding a UE-specific DRX cycle. This parameter structure can be included within an N-gap initial context setup request, UE context modification request, handover request, or path switch request acknowledge message. The tracking area identity TAI list is included to ensure that the base station broadcasts the RRC paging message using the appropriate cells. In many cases, all cells belonging to a base station will belong to the same tracking area. However, there are also deployment scenarios where the cells will belong to different tracking areas. For example, a base station which is shared between operators may have one set of cells belonging to a first tracking area for the first operator and another set of cells belonging to a second tracking area for the second operator. The paging priority can be included to prioritize specific paging messages at the base station. The priority can be configured with a value from 1 to 8, where 1 represents the highest priority. The AMF deduces a priority level from the allocation and retention priority ARP indicated by the SMF when requesting the AMF to page the UE. Specific services are likely to have high ARP priorities, example, mission critical services and multimedia priority services. The UE radio capability for paging provides the base station with information regarding the operating bands supported by the UE. This can be used to reduce the number of cells which broadcast the RRC paging message, that is, there is no need to broadcast a paging message on a carrier which the UE does not support. This parameter structure allows both 5G and 4G operating bands to be listed. The 4G operating bands are applicable when the 5G core network is connected to a next generation eNode B, that is, a base station which supports the 4G air interface. The assistance data for paging can be used to provide a list of recommended cells. This list can include cells which the UE has previously visited, and it can also include cells which the UE has not previously visited. In the case of previously visited cells, the AMF specifies the time that the UE spent in each cell. If the time is greater than 4095 seconds, then the AMF signals a value of 4095 seconds. The base station can use this information when selecting the cells to broadcast the RRC paging message. The AMF derives a set of recommended cells from information previously received from the base station. A base station can provide the AMF with information regarding recommended cells and RAN nodes for paging within the N-gap UE context release complete message. The AMF stores this information for any subsequent paging procedures. The assistance data for paging can also be used to provide the base station with information regarding the retransmission of N-gap paging messages. The AMF can specify the current paging attempts count and the total number of attempts which are planned. The AMF can also specify whether or not it plans to change the scope of the geographic paging area on the next paging attempt. The base station can use this information to help define its own paging strategy. For example, if the AMF is approaching its final paging attempt, then the base station can increase the priority of the paging procedure and potentially broadcast the RRC paging message across an increased number of cells. The paging origin flag is included when the paging procedure has been triggered for the PDU session, which is associated with a non-3GPP access technology. The UE uses the 3GPP access network to respond by sending a NAS service request message. This message indicates whether or not the PDU session can be reactivated using the 3GPP access technology. Once the base station has received the N-gap paging message, then it determines an appropriate paging frame and paging occasion for the RRC paging message to be scheduled across the air interface. The base station uses downlink control information DCI format 1_0 to allocate PDSCH resources for the RRC paging message. The CRC bits are scrambled using the I-RNTI to indicate that the PDSCH resource allocation is applicable to the paging procedure. Idle mode procedures. Let's get into the topic. Table on the screen presents the content of an RRC paging message. A single message can include up to 32 paging records, and each paging record can address a single UE. The RRC paging message allows the UE to be addressed using either its 5G STMSI or its full I-RNTI. The I-RNTI is applicable to UE which are paged from RRC inactive. The base station allocates an I-RNTI when moving a UE from RRC connected to RRC inactive. The UE initiates the random access procedure after receiving an RRC paging message. The RRC setup request message is sent to MSG3 using a cause value of empty access. A NAS service request message is included within the RRC setup complete message. The base station forwards this NAS message to the AMF to complete the paging procedure. For a UE in RRC inactive, the serving base station maintains a record of the UE location in the terms of its allocated RAN notification area RNA. The UE triggers an RRC resume procedure with cause value MA update if it moves outside the allocated RNA. The UE does not update the network while moving within the allocated RNA. In general, this means that paging messages must be broadcast by all base stations belonging to the allocated RNA. In the case of RRC inactive, the UE specific NGC connection towards the AMF and the UE specific NG-U connection towards the UPF are maintained. This means that the AMF can continue to forward NAS messages towards the serving base station and the UPF can continue to forward downlink data towards the serving base station. The serving base station is responsible for paging the UE to allow reception of the downlink NAS message or downlink data. Figure on the screen illustrates an example based upon the serving base station receiving downlink data from the UPF. The serving base station is reliant upon having an XN connection towards each of the base station within the RNA. The serving base station can then forward an XNAP RAN paging message to each base station. The XNAP RAN paging message is represented in table. Alternatively, all cells within the RNA may belong to a single base station using the CU or DU split architecture. In this case, it is not necessary to rely upon XN connectivity. The UE identity index value is set equal to 5G STMSI mod 1024, that is a value from 0 to 1023 which occupies 10 bits. This value allows the target base station to determine the paging frames and paging occasions without having to transfer the full 5G STMSI across the XN interface. The UE RAN paging identity is the full I-RNTI which was allocated to the UE within the RRC release message when moving the UE to RRC inactive. This identity is used to address the UE within the RRC paging message. The paging DRX specifies the DRX cycle used by the UE. This value allows the target base station to identify the appropriate paging frames and paging occasions. The RAN paging area allows the target base station to identify the cell which are required to broadcast the RRC paging message. The set of cells can be specified explicitly using up to 32 cell global identities (CGI). Alternatively, they can be specified using up to 16 RAN area identities. The use of RAN area identities relies upon each cell being configured with both a tracking area code and RAN area code. The paging priority can be included to prioritize specific paging messages at the target base station. The priority can be configured with a value from 1 to 8, where 1 represents the highest priority. If the paging procedure has been triggered by the reception of a downlink NAS message from the AMF, then a RAN paging priority may have been included within the NGAP downlink NAS transport message. The assistance data for RAN paging can be used to provide the target base station with information regarding the retransmission of XNAP RAN paging messages. The serving base station can specify the current paging attempt count and the total number of attempts which are planned. The serving base station can also specify whether or not it plans to change the scope of the geographic paging area on the next paging attempt. Figure on the screen shows the paging procedure used to notify UE of a change to the system information or an incoming ETWS message. This procedure is applicable to UE in RRC connected, RRC idle, and RRC inactive. In this case, the paging procedure does not use NGAP, XNAP, nor RRC paging messages. Instead, the paging procedure uses only the payload of the PDCCH. Downlink control information DCI format 1_0 can include a short message when the CRC bits are scrambled using the I-RNTI. This short message can be used to indicate that system information has been updated and needs to be reacquired, or there is an incoming ETWS message. UE in RRC idle or RRC inactive monitor the PDCCH once per DRX cycle during the UE's paging occasion. UE in RRC connected monitor the PDCCH once per system information modification period during any paging occasion. Assuming the UE has been configured with a common search space to monitor paging within the active bandwidth part. If the UE is paged with a system information change notification, then the UE reacquires the system information from the start of the next modification period. If the UE is paged within an ETWS notification, then the UE immediately reacquires SIB1 and checks for scheduling information which is applicable to SIB6 or SIB7 for ETWS and SIB8 for CMAS. The UE then proceeds to acquire the relevant public warning system SIB. Base stations which use multiple beams to provide coverage across the cell area are required to broadcast paging messages across all beams. For example, a base station which uses 8 beams to provide coverage will be required to transmit each paging message 8 times. This means that paging occasions must allow sufficient time for UE to scan all the beams.